Hello, ladies and gentlemen. Welcome to Math 30-3, Chapter 6, Section 2, Transformations, Rotations, and Dilations. Now, today, we're going to determine and explain whether a given image is a dilation of another given shape using the concept of similarity. We're going to draw with, concept of similarity, my apologies. We're going to draw, with or without technology, a dilation image for a given 2D shape or 3D object, and explain how the original 2D shape or three-dimensional object and its image are proportional. And we're going to solve a contextual problem that involves transformations. So, rotation, we end up moving, rotating around a point, usually the origin. Notice how we're going like this. A dilation, on the other hand, we're getting bigger or smaller. Notice how we went from this smaller box, or smaller rectangle, to a bigger rectangle. Dilation. Now, first things first, working with rotations. Rotation is a transformation in which points of an object are turned about a fixed point called the center of rotation. The center of rotation. In order to perform rotation, you must know the degree and direction of the rotation. You must know the degree and direction of the rotation. Okay, so let's do some examples. Using the origin as the center of rotation, rotate the shape 90 degrees, 180 degrees, and 270 degrees clockwise. Now, clockwise, you go that way, like the minute hand of the second hand or the hour hand of a clock. State the coordinates of the translated vertices. So this point A is on the origin, it doesn't move. Let's look at point B. That is 1, 3. Now what happens here, it rotates 90 degrees, so it comes down here to be at 3, -1. Point C is here at 1, 2, 3, 4, 4. It rotates down here to be at 4, -4. And of course I just covered up the other point here, point D, at 3, 1. That rotates down here to be at 1, -3. So a new shape, and connect the dots, goes like this. So that's rotated 90 degrees. Alright, now, you guys can draw the other ones, but I want to show you the shortcut. What's happening to all these points? Well, let's look at, this is, B prime. This gets rotated down here, so it becomes, I should move that out of the way, shouldn't I? Getting a little messy here. This becomes, what was I going to say? Oh, yes. -1, -3. Notice 1 to 3, 3 to -1, -1 to -3. The numbers flip, and they go from positive to negative as you rotate. So that means the last point will be up here, 3, -1. Yeah, but I'm getting ahead of myself. Now, this point 4, -4 will become over here. -4, -4. And, -4, -4 is down there. Never mind. And this point was, 1 and -3. What's the point here? 4, 4. 3 and -1 becomes -1 and -3. 1 and -3 becomes -3 and -1. So we end up like this. That's a third rotation. This is just getting messy. But I want you to see like that. God, this just hurts my brain. And that's the fourth one. I'm not going to do that, that just hurts. Let's state the coordinates of the translated vertices. You see what's happening to them. The numbers are flipping, they're becoming positive and negative as they rotate. this was minus 4 and minus 4, so when it flips up here, it'll be minus 4 comma 4. I know, it hurts my brain. Giving me a headache. Now, rotate the following shapes around the origin in the direction and degrees indicated. 180 degrees clockwise. So clockwise means going like this. So point A is here. So that is minus 3, minus 1. That will rotate up this way. And it rotates like this. 3 comma 1. That's probably the easier way to do it. The next point B is here, 1 and 1. A rotation of 90 degrees, we'll put it here. Rotation of 180 degrees, rotation of 90 degrees, we'll put it here, And 180 degrees, we'll put it there. At 1 comma 1. Point E is 3 and 3. So that goes 3 and 3 over here. That's 90 degree rotation. 180 degree rotation, we'll put it here at 3 and 3. Point C is 3 and 1, so that's 1 and 3 here. Then 1 and 3 C prime. 1 comma 3. And then point D is right here. That's 4 up and 2 over, so it goes 2 and 4. And rotates like this, becomes 2 and 4 up. So there it is, 180 degrees clockwise. That hurts. Let's do the next one, 90 degrees clockwise. This one's easier. Point B was 3 units that way, so 90 degrees will be 3 units that way. A is 3 and 3, so 90 degrees will be 3 over and 3 up. There's A prime. And C is here. 1 up and 3 over, that becomes 1 over, 3 up, there's C prime. Then I play connect the dots, and there's the new shape, rotated 90 degrees clockwise. Okay? Now, let's do a couple of harder questions. The shape in the first quadrant is rotated 90 degrees counterclockwise about the origin. What quadrant will the resulting image be located? So, here we are in the first quadrant. It gets rotated counterclockwise. Now, clockwise is this way. So counterclockwise is this way. It's going to end up over here in quadrant 2. Now, say this is 4 and 1. What happens when it gets rotated? Well, it goes up 4 and over 1, or minus 1 and 4. X and Y flip, and the X becomes negative. In accordance, X becomes Y, Y becomes minus X. So, I know that's a little nasty. Say this point is 3 comma 5. Over here, this will become, X becomes Y, this will become 5, and Y becomes, the X becomes the Y. So that will be, 3. So the Y value will be 5. Stop it, Mr. Sutton. X becomes Y, so X is 3, so this becomes the Y. The Y value becomes the minus X. Minus 5, comma 3. Okay, I'm kind of hoping you notice that. If not, don't worry too much about it. You can always go, this is over 3 and up 5, so this becomes over 5, up 5, and over, up 3 and over 5. Anyway, just going to stop there because it hurts my brain. Now, Misha is designing the propeller for a toy helicopter. The blades need to be evenly spaced around the origin. That is, 3 of the blades must be 90, 180, and 270 rotations of the first blade. Misha has drawn the following sketch of the propeller. If blade 1 is correctly placed, which of the other 3 blades is incorrectly drawn? Okay. So here, see, we all have the origin. Okay, that's good. So let's choose a point here. 1, 2, 3, 4, 5, 6. So this is minus 6, comma 6. Okay. So that coordinate, and that coordinate. Which one of these don't match up? Well, this is 1, 2, 3, 4, 5, 6. Now notice, no, I'm doing the long straight side here. This corner on the long straight side. Okay. So one of them is, at least one of these is incorrectly drawn. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This is 6, comma 5. So this one is wrong. This is 1, 2, 3, 4, 5. This is 6, comma minus 6. So that works. This one is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Oh, sorry. This is minus 6, comma minus 6, which does work. So number 2 is incorrectly placed, I think. Now, we should check another point just because we can. This point here. Minus 1, comma 3. This point is 3, comma 1. This point is 1, comma minus 3. And this point is minus 3, comma... Yep. This one is original. That one is wrong as drawn. The others look to be correct. Just double checking, right? Now, that's it for rotations. I'd like you guys to do that first handout, rotations, in page 1920. When you get that done, we'll come back and we'll do dilations, all right?